an independent event are the ones we've talked about. And that's really where the unit is going after today's lesson. But essentially, an independent event just means one event has no effect on the other one, which is pretty much what you're dealing with here in probability. So the probability of A and B, these are two different events. They are definitely independent. We are told that they are independent. You kind of need to be told that. The probability that both of them will happen, right? It doesn't necessarily mean that A happens first and then B happens, but it's kind of written that way. But the probability that they both happen, it could be at the same time. If they are independent, all you do is take the probability of one and multiply it by the probability of the other, right? And then it's a much smaller chance of it happening, right? Which makes sense because, you have one event that's probably not super likely to happen. So like, what's the odds of that one happening and then another event actually happening too? So you would never add them. I know people see and you'd say add them, but if you added two probabilities, the probability would go up, which makes zero sense because it's like, man, two things have to happen. The probability would definitely go down. Drawing an ace and then another ace, if you replace the card, like that would be a much lower probability than drawing just one. So these numbers will always be multiplied because when you multiply fractions, you create smaller fractions, which would translate to a much smaller percentage of something happening, right? So here's some examples of just things that, are probably obviously independent events, outside of drawing cards and rolling dice and flipping coins, right? If your pencil breaks and it's rainy, probably not related to each other, they're probably independent. You could find the probability that both happened as long as you had the probability of each individual one simply by multiplying those two probabilities together, right? Celtics and Red Sox winning, probably the Celtics winning doesn't have an effect on the Red Sox winning and vice versa. The price of tea in China and Susie posting on Billy's Facebook wall, right? Independent, unless, however, the post was about the price of tea in China, in which case they would actually be dependent, which that's 6.3, don't worry about it, all right? So here's a quick multiple choice. I'm going to post this video as a second video that I want you to watch as soon as you're done with this one. It's good definitions in there, like mutually exclusive. You want to make a note of that, and there's some other things in there. So watch that one after this, but do the multiple choice first and see how you guys do here. And then resume the video when you got it. All right, so we got 150 raffle tickets for a mall gift card, 200 raffle tickets for a movie passes. You buy 5 raffle tickets for each, right? So that would give you 5 out of 150 of winning the mall gift certificate, which I'd always reduce, right? 5 over 15 is going to be 1 over 3, so it's going to be 1 over 30. So you have a 1 in 30 chance of winning the mall gift certificate, and then you bought 5 for the booklet of movie passes. So there's 5 favorable outcomes out of 200 possible, which I'm just going to reduce that. 5 over 20 is 1/4, so 5 over 200 is going to be 1/40. And if you wanted to win both, that's the probability that both of these things happen. You would have to multiply these two. So 1 over 30 times 1 over 40 should give you B, which is 1 over 1200. Another example, just phrased a little differently. I'm telling you in this example that you have an 8.33% chance of rolling a 5 on a dice and then flipping heads on a coin. I'm telling you, both of those things happening, I'm giving you the probability that both happened. Are these two events independent, right? Well, we can figure out the chance of rolling a 5 on a dice. There are 6 sides on a dice. 6. That was dumb. And the number 5 is only one favorable outcome. There's only one favorable outcome out of the 6 possible outcomes of the dice, right? The number 5 is your only favorable outcome. Probability of B, flipping heads on a coin, would be 1 and 2. So if you have the probability that both happen, if they truly are independent, that means you would multiply this times this, and you would get whatever that number means. Whatever that number is would be your independent events. Obviously, we know these two things are independent, right? There's no way that rolling a 5 would somehow affect getting a heads on a coin, but it's kind of a silly example. But you do 1/6 times 1/2, and you get 1/12, which 1/12 happens to be 8.33%. So the answer is yes, right? Because this number that we got is the same thing as the probability of A and B, then we're just confirming that these things are independent. If we had multiplied these two things together and it came out to be something different than 8.33%, Well, that means for some reason these events are not independent because you got a different percentage, right? One had an effect on the other, which wouldn't ever happen with rolling dice and flipping coins, but it could happen with other things, which is, again, where 6.3 will go. This is just another example. If I called on 3 boys to answer the next 3 questions if I was in class, we would say that's independent, right? Didn't matter who I called on the first time. I could still call on that person again, which would be different if I called on, Mills to answer a question and then I couldn't call on him again. Well, then all of a sudden, the fact that I called on a boy the first time now affects the likelihood a boy gets called on the second time. It would be a lower probability. If I took out a boy out of the entire sample space, the probability would change, which means they're actually dependent events. But in this case, I can still call on the same person again and again and again, and let's just say it really is at random. So the probability that I call on a boy the first time, boy the second time, boy the third time would just be the probability, of all independent. I may have 2 different sections, so it'd be different in each class, but you would just take the same number and multiply it by the same time 3 times, and you'd get that, very low probability that it would actually happen. The last definition I have for you guys in this video is just a complement of an event, which is simply the probability that the event does not. It's actually, let A be an event and A prime be its complement. The probability of A is probability of A. The probability of the complement is A is 1 minus the probability of A. All that means is the probability that 3 boys aren't called on. It's not the opposite, which I think was what I was about to say. Because it doesn't mean the probability that 3 girls get called on. It would just simply mean the probability that 3 boys do not get called on, which could be 2 boys and 1 girl. It could be 2 girls and 1 boy. It could be 3 girls, but it doesn't really matter in that regard. So all of the things that don't fit the event happening would be part of the complement.